Today's lesson is lesson 4.1, graph using slope-intercept form. So first we have to know what slope-intercept form is. So slope-intercept form is y equals mx plus b. So notice that equation is solved for y. So our y is a variable, our x is a variable. The m and the b are going to be numbers where m stands for your slope and b stands for the y-intercept. So if we have an equation that is in slope-intercept form, meaning we have y equals mx plus b, that means the letter m, whatever number is in front of x or the coefficient of x, is going to stand for the slope, or we could call that the rate of change of our line. So that's going to be your slope. So in other words, this is also going to tell us our rise over our run. How is my graph moving up and down compared to how it's moving left and right? And then we have the plus b. That will not always be an addition sign. That will depend on whether your y-intercept is positive or negative. So this does stand for the y-intercept. And remember, your y-intercept is where your graph crosses your y-axis. So the ordered pair is always 0, comma, and number. And it will say plus b if your y-intercept is positive. And it will say minus b if your y-intercept is negative. So that won't always say plus b. It might say minus b. So you need two pieces, the slope and the y-intercept. So how are we going to use this to graph? Well, the first thing is we need to make sure the equation is in slope-intercept form, that it's solved for y. But then what you need to do is you need to make sure you can identify which number represents the slope and which number represents the y-intercept. And then we're going to relate this to your cell phone. So you probably don't drive yet, but most of you have a smartphone. And at some point you're going to use your smartphone to get directions somewhere. And so if I wanted to get directions somewhere, the first thing my phone has to do is it has to locate where I am. And so that's exactly what we have to do when we graph on a coordinate plane. We have to know where we are on the coordinate plane. And the part of that equation that's going to tell us where we are located on the coordinate plane is the y-intercept. So you first have to plot the y-intercept on the y-axis. So we have to know where we are on that coordinate plane. So we're going to locate that y-intercept. Then your phone, once it knows where you are, your phone is going to start giving you directions. They're going to give you turn-by-turn directions. And so just like your phone starts giving you turn-by-turn directions, we are then going to use the slope, which is going to tell us turn-by-turn directions, how we're going to move. Are we going to move up or down? Then are we going to go left or right? So we're going to start at that y-intercept and we're going to count the slope. We're going to count the rise over the run to find our next point, and then we will draw a straight line through all of those points. So if we look at example 1a, we notice that we have a slope of 1/4 and a y-intercept of -1. So the first thing we want to do is we want to graph our y-intercept on the y-axis. So I'm going to plot -1 on the y-axis. So in other words, we're talking about the point 0, -1. So we're going to go to 0, -1. Now that we know where we are going to count our slope. Now our slope is 1/4. So that is telling me my rise over my run. Since these are both positive numbers, that means I can go up 1 and then right 1. So from my y-intercept, I'm going to count up 1 and then right 4. I think I said up 1, right 1. That's up 1, right 4. So up 1, right 1, 2, 3, 4. Now, you don't technically draw those lines that I just did. I was just showing you how to count. So you're going to go up 1, right 4 every time. Up 1, right 1, 2, 3, and 4. Now, let's say you couldn't go up 1 and right 4. You do have another option. We also know that a -1 over a -4, a negative over a negative gives us a positive. So we could also count down 1 and left 4. So I could also count down 1 and left 1, 2, 3, 4. Down 1, left 1, 2, 3, 4. And then we always connect those ordered pairs with a straight line. And we put arrows at the end because lines go on forever. And always verify that if your slope is positive, that your line is rising from left to right, and it is. And so if you notice at the very bottom, we're going to write the equation. So it's always y equals my slope, which is 1/4 times x, plus or minus my y-intercept. Since my y-intercept is negative, I'm going to write -1. So my equation is y equals 1/4 x minus 1. For b, if we look at b, I'm going to notice that my y-intercept is 3. So I have to plot my y-intercept first, always. So my y-intercept is 3, so I'm going to plot 3. And then my directions. My directions tell me where I'm going to go from there. So what's my rise over my run? Well, my slope that I've been given is -4. So my rise is -4, and all whole numbers are always over the number 1. So my 4 is negative, which means I'm going to go down. And then my run is positive, which means I'm going to go right. So from my y-intercept, I'm going to count down 4, 1, 2, 3, 4, and right 1. And I'm going to go down 1, 2, 3, 4, right 1. Down 1, 2, 3, 4, and right 1. I also have the other option because I also know that a negative over a positive is a -4, but also a +4 over a -1 would also give me a slope of -4. So I could also count up 4 and left 1. So 1, 2, 3, 4 up and left 1. And then that's all the points that will fit on my graph. And I'm going to draw a straight line, making sure I put arrows on the end. Then I'm going to come down and write my equation. Y equals my slope, which is -4 times x, and then my y-intercept is positive, so I'm going to put +3. Notice in my equation, I don't write my slope as -4 over 1. We don't write it like that. -4 over 1 is just -4. Now, if you're given equations, you just have to pull the information from the equations that are already written. So in this first equation, I have to identify my slope, and my slope is always the coefficient of x as long as my equation is solved for y. And notice it is y equals mx plus b. So my m is 1/2, so that means my slope is 1/2. And my b is a -8, so that means my y-intercept is -8. I could also write that as the ordered pair, 0, -8. So I'm going to plot that y-intercept, -8. And then I'm going to graph from there using my slope, which tells me my directions. Where am I going to go? My rise over my run. So my slope is 1/2, which tells me I'm going to go up 1 and right 2. So I'm going to go up 1, right 2. Up 1, right 2. Up 1, right 2, up 1, right 2, up 1, right 2. Or we also know a negative over a negative will give me a positive as well. So you could also go down 1 and left 2. Down 1, left 2, down 1, left 2. So verify my slope was supposed to be positive. And if I look at my line is increasing or going uphill from left to right. So I know I counted my slope correctly on that one. If we look at example B, we do look and we see that this is solved for y. Y equals mx plus b. But we notice that we do have an m. M is -3. But then my plus b, I don't have anything after my negative 3x. So if there's nothing there, there's really a plus 0. You will just never see it. So your y-intercept is actually 0. So you have a y-intercept of 0, 0. So I'm going to plot my y-intercept first. Once I know my y-intercept, I always then use my directions, my turn-by-turn directions, which is my rise over my run. So my rise is negative 3. All whole numbers are over 1. So this tells me to go down 3 and right 1. So I'm going to go down 3, right 1. Down 3, right 1. Down 3, and right 1. We also have the availability, since a negative over a positive is a negative, I also know a positive over a negative is a negative. So that could also go up 3 and left 1. So up 3, left 1. Up 3, left 1. Up 3, left 1. And then we connect those with a straight line. And we put arrows on the end to show it goes on forever. Notice my slope is negative, and that's going downhill from left to right. For our next two equations, they are not solved for y. They are not in slope-intercept form. So unfortunately, in order to graph these by slope-intercept form, we are going to have to solve each equation for y. So I'm going to take my negative 2x plus 5y, and I have to get y by itself. So if I look at my y, I have a negative 2x over there that should not be there, and a 5. So the first thing I have to do is I have to move my 2x over to the other side. So I'm going to undo a negative 2x by adding 2x. So I'm now left with 5y equals 2x plus 10. 2x and 10 are not like terms, so you cannot combine them. Then I'm going to undo multiplication with division. But when I divide by 5, I have to divide everything by 5. And so I am left with y equals, and 2 divided by 5, 5 doesn't go into 2, so we're just going to leave it as 2/5 x plus, and 10 divided by 5 is 2. So this is now in slope-intercept form, where my y-intercept is 2 and my slope is 2/5. So I'm going to plot that y-intercept first. I'm going to plot 2, and then I'm going to count my slope, which is 2/5. So 2/5 means I'm going to go up 2 and right 1, 2, 3, 4, 5. Up 2, 1, 2, 1, 2, 3, 4, 5. I also know, though, that when we're talking about a 2/5, a positive over a positive is a positive, but I can also do a negative over a negative and still get a positive. So I can also go down 2 and left 5. Down 2, left 5. Down 2 and left 5. And then we'll connect those all with a straight line and put arrows on the ends. Letter D is the same way. Letter D is not in standard form, or sorry, it is in standard form, but it is not in slope-intercept form. So on our problems where we have to solve for y to get it in slope-intercept form, it's super important that you pay attention to your signs. If we don't pay attention to signs, we're going to make a mistake, and then it's going to make our entire problem incorrect. So the first thing I need to do is I need to subtract 3x from both sides because I'm trying to get a y by itself. So on the left, I have a negative 4y left, not just 4y, but a negative 4. There's a negative in front. Then my 12 and negative 3x are not like terms, but I'm going to write down the negative 3x first so that it looks more like in slope-intercept form, and my 12 is positive. And then I have to make sure I divide each term by negative 4. Well, obviously my -4 divided by -4 cancels, but this is where we need to be careful. A -3 over a -4, a negative over a negative makes a positive. So I just write that as a positive 3/4 x. And then a positive 12 divided by a -4 is a -3. So I write that as -3. So I have a slope of 3/4 and a y-intercept of -3. So we're going to plot our y-intercept of -3. And then we're going to count our slope, which our slope is 3/4. So I know that means I rise 3 and I run 4. So I'm going to go up 3 and right 4, up 3 and right 4. I also know that a negative over a negative makes a positive, so I can also rise a -3 and run a -4. So I can also go down 3 and left 4. So down 1, 2, 3, left 1, 2, 3, 4, down 1, 2, 3, left 1, 2, 3, and 4. And then we would connect all of those with a straight line, making sure to put arrows on the ends because it extends forever. And then last but not least, you should be able to write an equation from a graph that's already there. So you still have to identify your slope and your y-intercept. So if I look at this problem, I'm going to see that my y-intercept, so it crosses the y-axis at 0. So my y-intercept is 0. And then I have to find another ordered pair on that graph, and it doesn't really matter where it is. There's one down here. And I'm going to count my rise over my run. So I'm going to start at 0, 0, and if I start at 0, 0, I have to go down 2. So my change in y, or my rise, is a -2. And then I have to run, and from there I run to the right. And so my change in x is a positive 1, 2, 3, 4. So I have a -2/4, which reduces to -1/2. So my slope is -1/2. So my equation becomes y equals, my slope is -1/2. I always put an x. And then we never put a +0. If your y-intercept is 0, you will never see the +0. So we just write that as y equals -1/2 x. On letter B, you will notice that this graph crosses at a -1, 2, 3, 4, 5, and 6. So our y-intercept, it crosses at -6. And then we do need to find another ordered pair so that we can count our slope. And here's an ordered pair right there. So if I start at the bottom ordered pair, I have to rise and go up, and I go up 1, 2, and 3. So my change in y would be 3. And I run, I go to the right 1. So my change in x would be a positive 1. And we know that 3 over 1 is just 3. So my equation would be y equals my slope, which is 3, times x, and then my y-intercept is a -6, so I write -6. And last but not least, we have the two special cases. So if I look at example C, I notice that I have a horizontal line. So in my horizontal line, I'm going to look at 2 points. Well, first of all, I see that it crosses the y-axis at 2, so my y-intercept is 2. But then I have to choose any other point on this line. It doesn't matter which one. I'm going to choose this one. So my rise says, do I have to go up or down to get to my next point? And I don't. So what number represents not moving up or down? That would be a 0. So my rise is 0. But in this case, I did have to run. I went over 1, 2, and 3. Well, 0 divided by 3 is just 0. So when I write this, I get y equals 0x plus 2. However, 0 times x is 0, so we never write 0x. If you have 0 x's, the x term is no longer there, and this is y equals 2. So a horizontal line is always y equals a number. So when you have a horizontal line, it's always y equals a number. Now on letter D is a little bit different. If you notice, if I look at my y-axis, that line does not cross the y-axis at all. So I do not have a y-intercept, which means I'm not going to be able to write this in slope-intercept form. And I also notice that if I choose 2 points, I do have to rise. Like for this one, I rose 2, but then I did not have to go left and right. And remember, we talked about 2 divided by 0 means I have an undefined slope. So I don't even have a slope. So I can't even write this in slope-intercept form because I don't have a y-intercept and I don't have a slope. But what I do know is that in every single ordered pair in this line, x is always -5. So if I look at this line and I look at this ordered pair, that is -5, 0. And this ordered pair is -5, 1. And then we have the ordered pair -5, 2. So if you notice, in every single ordered pair, x is always -5. So when we have a vertical line, our vertical lines are always x equals a number. So they can't technically be written in slope-intercept form. And that's how we write equations of lines.